Our moon is more than just a light in the night sky. It is a silent partner in the story of Earth. It is our planet's closest celestial companion, bound to us by the invisible force of gravity. This constant pull is the engine behind our ocean tides, the rhythmic rise and fall of the sea. The moon's gravitational influence also acts as a crucial stabilizer for our world. It helps to keep Earth's axial tilt steady, preventing it from wobbling chaotically. Without this stabilizing presence, the predictable seasons that life on Earth depends upon would be thrown into disarray. Our planet, and the life it harbors, would be fundamentally different. Now, let us engage in a thought experiment. Imagine we could perform a cosmic switch. We carefully remove our familiar moon from its orbit. In its place, we introduce one of Saturn's many moons, perhaps Titan or Enceladus. The arrival of a new moon would initiate a complex and dangerous orbital dance. Gravity depends on mass and distance. A Saturnian moon, plucked from a distant orbit, placed near Earth would have a different velocity and trajectory. Its initial path would be highly elliptical, swinging very close at perigee and far away at apogee. This unstable arrangement would create immense gravitational stresses. The new forces could make it overshoot, crash into Earth, or be torn apart by tides. Even if it settles, that initial instability would be a time of great peril for our planet. If it comes too close, crossing the Roche limit, tidal forces overpower the moon's own gravity. The moon would be ripped apart, rock and ice disintegrating into debris. That debris could form a dangerous ring system, stunning to behold and threatening. The most immediate and dramatic effect of a new moon would be felt in our oceans, tides. Replace our moon with Titan, and the gravitational pull on our oceans increases significantly. Higher highs and lower lows would push coastlines inland, creating unprecedented, persistent flooding. Storm surges would become far more destructive, turning dangerous events into unstoppable deluges. Erosion would accelerate. Maps of continents would need to be redrawn. A smaller moon would weaken tides, seeming beneficial, yet ecologically disruptive. Tidal flushing would slow, nutrient mixing drops. Entire marine food webs would feel the strain. Species tuned to tidal rhythms would see cycles disrupted, risking population collapse. Stronger tides also break Earth's rotation faster. Days lengthen over geologic and perhaps historic timescales, disrupting day-night cycles. One profound role our moon plays is that of a planetary gyroscope. Earth's 23.5-degree tilt gives us seasons. The moon's torque prevents large variations in tilt and keeps precession slow and stable. A different mass or distance weakens this grip. Tilt could swing dramatically over long periods. With no stabilizer, tilt might drop to nearly zero, no seasons, or swing toward 85 degrees. The climate would lurch between extremes. Agriculture fails across vast regions. Complex life evolved under relative stability. Erratic seasons stress ecosystems. Some species adapt, many go extinct. Food webs unravel. Human civilization, built on stability, would face an existential challenge in a world that wobbles. The appearance of our night sky would be transformed. Our moon's phases mark time and paint the night with a gentle glow. Titan, larger yet dimmer, is shrouded in haze that absorbs and scatters sunlight, yielding a faint orange orb. Icy moons reflect intensely. Smaller disks could outshine our current moon, washing out fainter stars and the Milky Way. If torn apart, a luminous arc of ice and dust would become the most breathtaking feature of all. These changes aren't merely aesthetic. Altered brightness disrupts nocturnal rhythms across land and sea. Humanity's calendars, stories, and science are entwined with our moon. A new sky severs ancient ties. The familiar crescent, half and full, would give way to something alien, forcing us to rethink our place beneath the heavens. Long-term habitability is a delicate, complex equation. Worlds must stay stable for millions to billions of years for life to emerge, evolve, and diversify. Our moon is central to Earth's stability, moderating climate and guiding planetary evolution. Replacing it, especially with a different mass, could jeopardize Earth's status as a living world. Catastrophic short-term effects are only the start. Deep time swings threaten complex ecosystems. Frequent global resets could keep life simple, preventing the rise of complexity. The moon's gravity slightly flexes Earth's interior, while minor versus internal heat changes can echo over eons, including our magnetic shield's resilience. The Earth-Moon system is a finely tuned partnership. From day length to tides to seasons, our world is tied to this relationship. A new moon rewrites the rules toward iceball, hothouse, or chaos. One dramatic outcome is the birth of planetary rings as a moon is torn apart. Fragments spread along the orbit, building a vast, flat ring around Earth's equator. Spectacular and perilous, the rings would feed a constant rain of particles, beautiful but ominous. Bigger chunks threaten satellites, stations, and future travel, turning orbit into a shooting gallery. Aerosols could cool by reflecting sunlight, or warm by trapping heat, weather, and chemistry shift. Rings evolve, particles collide, perturb, and spiral inward, escalating impacts from light shows to real danger. A beautiful crown, born from a shattered moon, would shadow the world below. This fantastical swap reveals a profound truth about our place in the cosmos. Earth's habitability rests on a delicate gravitational harmony. Emerging planetary defense teaches us to nudge orbits, deepening our grasp of celestial mechanics. One distant day, scaled technologies might reshape environments. But today, this is science fiction. The urgent lesson is stewardship. Understand and protect the balance we have. Our moon is a guardian, a stabilizer, and an essential part of what makes Earth Earth. It leaves us with a humbling and vital question. Knowing how delicately our world is balanced, what is our responsibility to preserve that balance for all future generations?